Okay, so we're going to learn about conversions with moles or mole conversions. Now, one of the prerequisites that you need to be able to do this lesson is you have to be familiar with dimensional analysis skills. So if you are unfamiliar with that, please click the link to get to the dimensional analysis lesson and brush up on that. Okay, so with mole conversions, you have to remember all we're doing is we're making conversion factors that have the unit of the mole in them. So here's what I mean by that. So you can go from moles to grams. So if I give you a certain amount of moles and I say, can you please tell me how many grams that represents? You can do that. You can do that by using the molar mass. And if you remember the unit for molar mass, it's grams per, do you remember? Mole. Well, right there, doesn't this look like a conversion factor? So if you knew what compound you were talking about, if you were talking about moles of carbon, then you could relate that to grams of carbon. Do you remember where you could find that? Look at element number 6. What is the molar mass of carbon? 12.01 grams per mole. So you'd write 12.01 grams is equivalent to 1 mole. And if grams was on the denominator, that's okay. You just write the correct number next to the correct unit to make that conversion factor true. So if you know dimensional analysis, you already know how to do this. All you're doing is using conversion factors that contain the mole. There's a couple other ones to remember. Well, what if I told you, hey, tell me how many atoms, the number of atoms, or it could be molecules, etc. If I give you 4 moles of hydrogen, how many atoms are in that hydrogen? Well, here you just have to remember Avogadro's number. And what does Avogadro's number tell us? It tells us the number of atoms or the number of things in a mole. So it could be things, whatever it is, number of things. In this case, I said atoms, but it could be anything: ions, protons, electrons, the number of things in 1 mole. Well, there's a conversion factor there, which should be recognizable to you if you went through the dimensional analysis study. So there's a conversion factor. Finally, the other one you need to know is that you can go from moles of a gas to the volume, or I'll put the unit, liters of a gas. And this is another conversion factor. It's just knowing the volume or the molar volume of a gas, and that's going to be 22.4 liters per mole. Now I could extend this line out and write a number 1 under here, and you would see the conversion factor better, but we can just show it like this. Now, if you're in an IB course, it's going to be 22.7 liters per mole at standard temperature and pressure. The difference is that depending on what course you're in, they use different standard temperatures and pressures depending on if you're, in the United Kingdom or if you're in the United States. It just depends on which system you're using. So don't let that bother you. We'll use 22.4 for our examples. So again, there's a conversion factor there. So let's give an example of each one. I'll use a different color here. So you can go from moles to grams or grams to moles just using this conversion factor. So let's say I gave you a problem and I said you have 32 grams of let's do sodium. That's an exciting element. And I asked you, well, how many moles of sodium do you have if I gave you 32 grams? Do you remember the second step? We wrote what was given, the number, the unit, and the formula. Right, times fraction bar. Remember the third step? Bring down the unit and the formula since we're doing chemistry here. Now the fourth step requires a little bit of thinking. Where did I ask you to go? I asked you to go to moles. You need to ask yourself, can I simply go from grams to moles? Absolutely. It's very simple because it's just a molar mass relationship. Now from here, you need this. What is the molar mass of sodium? Which sodium has 11 protons. So you should be able to find it. Right, 22.99 grams per mole. So 1 mole of sodium has 22.99 grams, or is equivalent to 22.99 grams. So then at this point you're done. All you did was set up the dimensional analysis, and notice the only thing that's a little different is that we're using moles in our conversion factors. So 32 divided by 22.99 equals, and we're going to have two significant figures, so that'll be 1.4. Let's go back. That'll be 1.4. What's the unit? Well, we cancel this because that cancels that, right? These cancel each other out. 1.4 moles of sodium. That wasn't bad, right? It's just dimensional analysis, and don't let the different units and formulas, or don't let that confuse you or become an obstacle. It's just as simple as converting, decimeters into centimeters and, millimeters, all that stuff, what have you. Let's do one with Avogadro's number. So let's say if I gave you, let's say you started out with 4.7 moles of carbon, and I want to know how many atoms of carbon do you have? Okay, well, you know what's given. That's step 1, 4.7 moles of carbon. Step 2, times fraction bar. Step 3, bring down the unit and bring down the formula, right? Step 4, we think a little bit. Well, can I go from moles of carbon to atoms of carbon? Absolutely. That's very straightforward. That's why we have Avogadro's number. And then we write in the proper numbers. Please don't write that 6.02 times 10 to the 23rd moles is 1 atom. You would be surprised how many times I see that. You have to know that it's 1 mole is 6.02 times 10 to the 23rd atoms. Okay, now we go back to our calculator here and carefully punch these in. 4.7 times 6.02 second function double E for times 10 to the 23rd power. Enter. I'm going to have two significant figures. 2.8 times 10 to the 24th equals 2.8 times 10 to the 24. What's the unit? Right. Cancel this. This cancels. Atoms of carbon. That's a lot of atoms of carbon. 2.8 times 10 to the 24 atoms of carbon. See, this isn't bad. See the conversion factor in here that was set up as we went through the steps? All right, let's do one more, doing the volume mole relationship. Now let's say I said, hey, you have 153 liters of O2, oxygen gas. Remember, oxygen as a gas has 2 oxygens. Here's a quick refresher or something to remember. If I have 1 mole of O2, how many moles of O do I have? Oxygen. Think about it. You remember? 2. 1 mole of O2 is equivalent to 2 moles of oxygen. Just make sure you distinguish that, because you don't want to get confused later on if you sub out O2 for O or O for O2. They're different. But for this, it shouldn't even bother us at all. So let's see. Step 2, times fraction bar. Step 3, bring down the unit, which is liters, and the formula, which is O2. Step 4, can I go from liters to moles? Yes, that's the molar volume of a gas relationship, moles of O2. I'm done. I'm in the unit that I want, right? I'm going to end up in moles of O2. That's where I want to end up. But now the question that I have is, what numbers do I write in? Well, 1 mole of a gas is going to be 22.4 liters of gas. Let's see if I can erase that little thing here that's messing up my number here. Just rewrite in the 4. Nice and neat. You want to be nice and neat when you do your chemistry, and you want to set this stuff up nice and neatly. Okay, and that's it. So we'll punch in the numbers, and we're going to go 153 divided by 22.4, 6.83 moles of O2. 6.83 moles of O2 is the answer. Do some more practice problems and just follow the steps of dimensional analysis as you understand these relationships, the molar mass, Avogadro's number, and molar volume of a gas. Just realize that these are just conversion factors that we can use. I hope this video is helpful. Have a great day.